So classic tutorial from Autodesk, which is filling a cup of liquid and then maybe have the cup pour out that liquid. I'm going to create a cup. I'm going to select the top, convert it into faces, delete them, maybe make the top a little bit bigger, and have some interesting design. Okay, so that's going to be my glass, and then I'm going to kill off the construction history. That's gone. Now you can take a look at this nParticles menu. Before that, we were using create emitter, which comes out from a point. If you emit from an object, just very quickly emit from object, and you can see that under P cylinder you have this emitter, so it's sort of under, like a child of the object. So turn off this plane, and I'm gonna hit play. It looks to be from each vertex of the object. We can go back to the emitter. The emission attributes emitter type is omni. Set it to surface, and you can see that the particles are coming out along the normals of each face. Okay, back to my P cylinder. Because we're filling up a space with nParticles, going to do nParticles. So fill object, you have to select that object that is that you want to fill with, and it needs to have space inside. So for this video, we're just going to work with resolution of 10 as a start, and then for the Y boundary, so 0 to 1, minimum Y, let's set it back to 0, and the maximum Y to be 0.8, and let's apply. So we see our particles fill up that amount of space. And what we need to do now is change the nParticle type back to sphere. Under the nParticle shape, shading, it's cloud, so let's turn it to sphere. Now we can see solid objects. Let's play. It's not moving because remember we had a gravity thing going on, so it's ignoring by default. So we've got to turn it on, rewind, and play. And it's falling through because there's nothing to collide with. So gonna select this container geometry, and under nMesh create a passive collider, rewind, and play, and you can see that the particles now respect that boundary that we've set. The particles are colliding with external objects, but they are not colliding with themselves, which can be seen here. They're not self-colliding, so we just turn it on, rewind, and play, and you can see that the particles are agitated, but after a while they settle down, and you can see that the particles now have volume. Each particle has volume, and it's sort of resting on the rest. Okay, so now the next thing that we want to do is to get them to rest but fill up about like 80%. Of course, the other thing that we can do is to fill the whole container up to the brim, and then when you simulate them, they go down a little bit. So we can try that. So just delete everything again. So select, have my cylinder selected, create nParticles to fill the object. So I might as well delete the rigid body. Let's do a 1.0 and apply. So now they fill up all the way, and we make them self-collide, and we don't ignore gravity, and we turn this container into a passive collider and play. Okay, so now at rest the particles fill up to 0.8, give and take. So the next thing is to change the shading, particle shape, change the shading into spheres. Okay, that's what we're gonna do. Then the next thing is to make it a little bit interesting, I'm gonna create another cylinder. So we're gonna insert the cylinder like a spoon or something, and then we're just gonna stir it around a little bit. Okay, and let's say this is a stirrer. I'm gonna give it a little bit of subdivision height. This time we are also going to set it as a passive collision object. Because it's passive, we can keyframe it first. I'm not at my first frame, so first frame, keyframe, translate and rotate with Shift W and Shift R. I can stop my particles from simulating by disabling my particles. We can also turn our nucleus on and off. So once the simulation engine is off, nothing simulates. Oops, I think I should turn on the nucleus and just see how many frames it takes for the particles to settle down. It looks like it takes all of 120 frames, so I'm gonna extend that to 240. Okay, so as long as it reaches 120 frames, my animation will begin. So turn off nucleus again, select this guy, move that keyframe to 120, and do the animation maybe in 25 frames. I can even hide my nParticles a bit. Okay, so that's and then I'll set my keyframe, and then that's what the motion is going to look like. Okay, since we're going to do some stirring, right, I'm going to do a group on this animation because the group's center is going to be the world center. Hit Ctrl G, and the world center is just in the center of the cup, maybe in frame 130. I'm just going to key my rotate Y to make a stirring action. Okay, so I'm gonna stir it like that. Okay, and set my key, so it will appear that this object is now doing a stirring action. Okay, that's it. So we just convert this guy to a passive collider. Okay, so you can see that we still have our animation, we can still adjust it. It's just that on the shape level, we have a rigid shape 2. So rigid shape 1 belongs to the P cylinder, and rigid shape 2, let's name this stirrer. Okay, now let's take our particles, unhide them, enable our simulation engine, which is the nucleus. Let's simulate from the start. Okay, so once it reaches 120, you can see that it's simulated perfectly. Let's add another 100 frames to that simulation and see it stop, see the particles settle down again, and you can see that they do it beautifully. Okay, for even more realism in our particles, we have a liquid simulation mode. So liquid simulation comes with behavior like incompressibility. So the liquid can't be compressed, so it always keeps the spacing around each other, but in the same time they have surface tension, so there tend to be a continuous surface when enough molecules of water are close enough to each other. So it's like a clustering kind of behavior. There's a viscosity kind of behavior that lava, jelly, and jam has, so they flow really slowly and they are really sluggish. Okay, so we can achieve that with all these values, but first we have to turn it on, so I'm just turning it on, and let's see how different the fluids behave. in our case they settled at about here scale. So 2 times is too much. 1.2, 1.6. There's something like that. So now the shape is slightly different. Let's do a very quick outpouring of that particle because I promised. So after you stir, so you can see that when I playing backward nothing happens, but every time I play forward simulation happens, and the Maya will try to solve how the particle should react going forward. So be very careful about that, because if I just play like that and then I rewind but I don't go back to the first frame and I keep playing forward, it will not be an accurate simulation, right? Only when I go back to first frame, you can see that it snaps back to the initial position. So that's very important. If your first frame is not frame 1, you can go to nucleus 1 under time attribute and start time. Okay, you can say that my first frame starting to activate is frame 20. Then thereafter, if you see that it starts simulating in frame 20, then if I jump to frame 10 and any frame before 20, it resets the particles. So that's good to know. If your frame starts at 1000 or 100 or even a negative number, be sure to set your start frame so that prior to that frame the particles are reset. Okay, if I set this at frame 1 and then my animation starts at like frame 70 and my range is like that, my particle system is never going to reset because it's never going to touch frame 1. Okay, so that's that. Very quickly gonna turn off the nucleus, or actually even if you just hide the particle objects, I don't think they will simulate. Okay, if you find out that it's not the case, please let me know. Leave a note, leave a comment, so that we all learn something together. At 100 and at 200, I'm gonna withdraw my stirrer. So set another key and withdraw it quite fast. So that it's no longer inside. Okay, and about the same time, the cup's gonna tilt over. I'm gonna set a key at 300, tilt it over at 90 degrees, and with the final position not intersecting the ground. Because of our shape, I'm gonna not rest it at 90 degrees. Well, it may be a bit floating, but yeah, I think that's good for now. Okay, it needs to move forward. Okay, so that's wonderful animation. Okay, at frame 10, some intersection going on, so I'm gonna go into world space and just set another key. Okay, and so let's bring back our particles and run our fabulous animation. Okay, so you can see with the new liquid properties, the particles are spaced out a little bit more, and the velocity of the stirring and the tilting of the container actually threw them out. So the next thing we notice is that the particles totally ignore the ground. So what we have to do is to maybe set the ground as a collision mesh, which is create passive collider. So let's play that back again. Great animation. So if we don't want that occasional spill, we could go back to that liquid simulation and set the rest density. Okay. Then the next thing is, if we didn't want it to spread around so far ahead, we could set the ground's collision properties to be quite a bit of friction. For example, like 3 instead of 0.1. You would start to see that once the particles they don't travel so much. You see that here. Okay. The next thing is you could set a bounce factor 0.25. So just now the particles were just sliding along the ground, but now with the bounce factor, the particles will start to have some kind of bounce. There's a bounce attribute for collision objects, but there's also a bounce attribute for particles as well. So particle attribute is 0, so the particles doesn't bounce at all, no matter how bouncy the ground is. So let's put a 0.2. So even intercolliding, they begin to bounce a little bit more. Can you see that? So if we make them bounce like 0.7, and we make the ground bounce like 0.5, see that bouncing? I love it that even after the pot tilts over, I'm gonna put 400. After a while, there are more particles coming out. Take a look at that. Sort of still coming out after that. So that's quite good. So we've managed to achieve what we said at the beginning of the video. The next thing that I actually want to show you is how to mesh particles. So once we go to nParticles, we can mesh it. This is sort of liquid-like behavior, but it's not liquid in appearance. So the next thing that we can do is do an output mesh. So we can generate an output mesh by coming to shading, blobby surfaces. So when we render them, I'm just gonna go into do a quick render. Let me save my file, do a render. Only in software S/W that you will get a blobby surface that is a continuous mesh that joins the particles together with the correct threshold. So we have to experiment a little bit. So, but the next thing that we can do to be able to view it in the viewport is go to particles and modify, convert the nParticles into polygons. So nParticles to polygons, and we don't see a connected surface because inside our rendering there was no connected surface as well. So what we need to do is it's connected to an nParticle, and the original particle systems has gone missing. It hasn't gone missing. The particle shape has been changed into an intermediate object here. So if I turn it off, I'll still get back my object, but by right it should be represented by the mesh surface. So it's good to keep it there, but don't panic. For a long time I thought that my particles were deleted or something, but if you go back to this particle object, you would still see the shape going on. So and we can still bring it back. Sometimes when we this polygon surface is the converted particles to surface. If I delete that, some of you might think that the nParticles got deleted along with it. Don't panic. Okay, we can just bring this back, and we can just go back to convert nParticles to polygons. Okay, so same thing happened. It turned the nParticles back to intermediate object. So the next thing that we want to do is to this converted object, which follows the meshing rules. Okay, so this output mesh. So now we can see, if we start to bring down the threshold, we will start to see a continuous mesh, but because of the resolution of the mesh isn't so as high, those little bits, okay, just for now, let's go and turn on that, turn off that intermediate object. So go back to the meshing properties, and we can up the number of triangles. So we're limited to 100 faces, and it's triangular meshes. I don't mind triangular meshes, so let's do 1,000 faces. If I drop my maximum triangle sizes, so it's limiting the resolution by number of faces and the size of the triangle. So let's drop them to like 0.1. Immediately we see it assume the shape of the particles. Okay, and lower down, let's hide that mark the cup for a while, and you see that where they are all concentrated together, it's a continuous mesh. Okay, and if we hide our particles now, okay, inside is a continuous mesh shell. Now the trick and the challenge is to make a blobby surface but not have the individual spheres. So let's do a scale. So we can scale them up so that we don't see, or down. So when we scale them down, we get lots of surface detail like this. Okay. Yeah, maybe that's good. Turn back on our container and use. I quite like things like that. Joining this kind of joining to each other and stuff. Okay, and then the next thing we can have is motion streak, which calculates the direction that the particles traveling and sort of have a motion blurred mesh, so to speak. So you see, when I increase that, these things are sort of moving forward, so you can see a tail forming in the geometry, which is quite an interesting representation. Okay, and as we step through, you can see them bouncing and creating a motion trail, and even when they are sort of being thrown forward, you can see those trails like that. And okay, and you sort of see them blend in with each other, so this Y shape. And okay, so that's quite interesting, but we still have this max triangle size, which is the size of this triangle, so we can still make it smaller, 0.6 maybe. So then when it gets too small, it becomes roundish, and then we can still set our threshold to be 0.9. Okay, so it's a balance between various parameters. Zero. Sometimes this is even better looking, because it gives us, it looks like lots of details but not showing the number of particles. Of course, the more particles you have, the more detailed shape you can make, but then everything else becomes more expensive to calculate, because more particle means more collisions. Let's go back to what I had with my last setting, somehow I couldn't get back to that one. Okay, so let's say I'm happy with this. And at any time, if I do a render, I now can see my mesh. So after meshing, you may find that it's eating out into your container mesh. So at that time, you might want to generate another mesh. For example, I'm gonna do a duplicate of that mesh. Oh no, I'm just to show, I can just push it out a little bit, just to push out that mesh to have the appearance that it's not intersecting. So the last thing, we should hide our particles. And finally, thanks for watching. I hope you learned something and it helped you with some of your problems. If you like what you're seeing, show some appreciation and leave some comments. Yeah, and if you're doing it in a slightly different way, but creative and helpful nevertheless, leave a comment as well. See you in the next video.